What is up, developers? Welcome back to another video. In this video, I'm going to show you how to make this colorful snowflake in Xcode and Metal. As we can see here, the snowflake starts with an equilateral triangle, and then we keep adding a bunch of other triangles, and you can keep going on like this forever. Let's see all about it. This is a Metal project, so we're going to start with some Metal boilerplate code. Let's have a look. This is the Fractal renderer. It has vertices, a reset triangle function, initialization, update buffers, a draw call. We're using a custom vertex with position and color, and here are the shaders. They just draw a simple triangle. Here's how we set up our points. These points are indexed 0, 1, and 2. That's the order we tell the graphics card to draw these triangles in. How do we make a new triangle? We need something that can make a new triangle out of any side. So here's something general. Take a side and the two vertices that make up that side. Subtract one vertex from the other to get a vector. 1/3 of the way up and 2/3 of the way up will give us our first and last points. In order to find that final vertex, let's rotate this vector by 90 degrees. To find where it's positioned, we need the height. In order to do that, we're going to use a tangent formula. Make sure to multiply the normal vector by the height. That way we can find the height of this new equilateral triangle. That's it! We created a new triangle. Let's repeat that for every single side. That's the first iteration. We also have to make sure to create new numbers for each of these points. These are the new outside indices. Here's the second iteration. You can see there's a lot more points. And the third iteration looks even cooler. So that's how we make new triangles. How do we send this all to the graphics card? We need to know that we have an array of vertices. And we need to make a new array of vertices using this new triangle creation function. Once we realize that there'll be 3 new vertices for every single pair, or every side, we'll realize that the new vertex count is the current vertex count plus the current vertex count times 3. If you look at how I'm making these new indices, it's very important because the outside indices are in order so that we can correctly identify which side they belong to for the next iteration. They're kind of sandwiched in between the existing vertices. Next, let's colorize our triangle. We see that it's just kind of white right now, which is fine, but I want it to look kind of fancy and real. So here's how I'll do it. In the shader function, vertex main, I'm going to add some unique floats. Those floats will be unique for the vertex ID. Then I need 3 different floats for R, G, and B values for the red, green, and blue that vary with time. I'll use a sine and a cosine function for these, and I messed around with these values myself to figure out what would look cool. Then I send the rasterizer data over to the fragment main function with these values. Now we can see that colorful snowflake is all done. A Caltech physicist who makes his own snowflakes said this, and I kind of agree. I mean, look at this, it's just the colorful, chromatic, rainbow colors. It's almost realistic because in real life, these snowflakes are made out of water, and when they're like crystals, they bend light in a way like a prism does, and a prism bends light into rainbows. So I thought this was really cool. That was all for this video on the colorful snowflake. Thanks for watching, leave a like and subscribe, and see you in the next source tutorial, developers.